There is a place on the Norwegian coast at 67 degrees north latitude, where the sea does something that defies the intuition of anyone who has ever stood near an ocean and believed they understood it. It is not a storm. It is not a tsunami. It is not the consequence of any weather event or seismic disturbance. It happens 4 times every single day with the mechanical predictability of a clock, driven by nothing more dramatic than the gravitational relationship between the Earth, the Moon, and the Sun. And it is the most violent sustained tidal event on the surface of this planet. It is called Saltstraumen. And what happens here is this: a 150-meter gap in Precambrian granite, rock that is 1.8 billion years old, older than complex multicellular life, older than the first fish, older than the first land plant, connects 2 bodies of water whose tidal phases are offset by approximately 6 hours. When the outer fjord rises and the inner fjord has not yet risen, the hydraulic pressure difference forces water through this gap. Not gently. The volume of water attempting to equalize through 150 meters of channel every tidal cycle is 400 million cubic meters. 400 million cubic meters of seawater, forced through a gap you could throw a stone across, 6 hours on, 6 hours off 4 times per day, every day for the last 10,000 years since the Pleistocene glaciers retreated and the sea first found this fracture in the rock. The result: a bore current of 37 kilometers per hour at peak flow. To understand what 37 kilometers per hour means in water, consider that the fastest Olympic swimmers reach approximately 8 kilometers per hour in a 50-meter pool, in still water at maximum exertion. The Saltstraumen bore runs at 4.6 times that speed continuously for 6 hours. It is faster than most people can run. It is faster than a rowing 8 at full sprint. And it does this through a natural rock channel with zero mechanical assistance of any kind, only gravity and the moon. But the velocity is not the most extraordinary thing about Saltstraumen. The most extraordinary thing is what the velocity creates. When a fluid of this mass and velocity is forced through a constriction of this geometry, it does not flow smoothly. It generates rotational instabilities, vortex structures, of a scale and persistence found nowhere else in the tidal world. At peak bore, Saltstraumen produces 7 simultaneous maelstrom vortex systems. The primary vortex reaches 10 meters in diameter. Its rotational velocity at the outer ring exceeds 35 kilometers per hour. At the center of the funnel, the water surface is depressed 80 centimeters below the ambient channel level. A hole in the sea 80 centimeters deep, rotating, sustained for hours, appearing and reappearing at the same position in every tidal cycle because the geometry of the channel floor that generates it has not changed in 10,000 years. The Norse navigators who first encountered this channel 1,200 years ago named the primary vortex Hafgufa, sea fog, sea breath, and encoded it in mythology as a creature that inhaled ships. They were phenomenologically precise. The funnel depression at the vortex center is, visually and physically, an inhalation. Something is pulling the water surface downward at that point. The Norse correctly identified that the something was large, persistent, located, and lethal. They were wrong only about the category. It is not a creature. It is fluid dynamics. The distinction offers limited consolation to anyone caught in it. The acoustic signature of Saltstraumen at peak bore is measurable from the seafloor as infrasound at 13 to 18 Hz, below the threshold of human hearing but felt in the chest at close range, transmitted through the granite cliffs as a structural vibration that the seismic sensors of the Norwegian Geological Survey can detect 40 kilometers away. The channel announces itself through rock. It has been doing so for 10,000 years. The rock has been listening for 1.8 billion. What you are about to watch was filmed over 48 hours of consecutive tidal cycles, with instrumentation never previously deployed at this site. What the cameras found, underwater, at the surface, and in the data, was not what anyone expected. Stay with this. The physics is only the beginning. If what you just heard made you want to see what comes next, subscribe. There are 5 more chapters and they get stranger. Everything that lives in Saltstraumen should not be able to live in Saltstraumen. That is not a rhetorical provocation. It is a biological fact that has puzzled Norwegian marine researchers since the first systematic surveys of this channel were conducted in the 1970s, and it becomes more puzzling the more thoroughly the channel is examined. The conventional ecological model predicts that environments with chronic extreme physical disturbance, current velocities that exceed the attachment capacity of sessile organisms, turbulence that disrupts feeding, hydraulic forces that exceed the structural tolerance of most marine invertebrates, should support low biodiversity and low biomass. Saltstraumen violates this prediction completely, thoroughly, and in ways that have required the revision of multiple foundational assumptions in temperate marine ecology. The channel wall at 10 meters depth, surveyed by the IMR during peak bore, carries a community so dense and diverse that marine biologists routinely describe it as one of the most productive benthic environments in the North Atlantic. Dead men's fingers coral, Alcyonium digitatum, in colonies averaging 22 centimeters diameter, covering 40% of available substrate. Plumose anemones, Metridium senile, in densities of 34 individuals per square meter, each one a three-dimensional filter-feeding structure 45 centimeters tall, fully extended into a bore current that would detach them from any substrate not anchored with the tensile strength of a steel cable. Horse mussels, Modiolus, in beds of 400 individuals per square meter, their byssal threads resisting hydraulic forces 23 times the force required to detach them from calm water substrates. And in the crevices, in the hydraulic shadows, in the dead zones behind granite buttresses, communities of species normally associated with low-current environments that have found, in a channel of world record velocity, the specific microhabitats of stillness they require. This is the first paradox of Saltstraumen biology. The same hydraulic violence that makes the channel deadly also makes it extraordinarily productive. The bore current delivers nutrients, oxygen, and suspended food particles to every point in the channel at 37 kilometers per hour. Every filter feeder in Saltstraumen receives a food delivery service operating at highway speed, 4 times per day. The anemone that would require weeks to filter sufficient food from a calm Norwegian fjord can meet its metabolic requirements at Saltstraumen in hours. The bore current is, simultaneously, the greatest threat to biological survival and the greatest driver of biological productivity that the Norwegian coastal environment contains. The fish community amplifies this paradox. Atlantic wolffish, Anoricas lupus, a species that weighs up to 25 kilograms, that crushes sea urchins with the strongest bite force of any temperate water fish, that is apex predator of its depth zone, lives permanently in this channel. It has a crevice at 14 meters depth on the north wall that it occupies across tidal cycles, wading through the peak bore at 37 kilometers per hour, emerging during slack to feed, returning, waiting. It has inhabited this crevice or one like it for its entire adult life. The channel has not discouraged it. The channel has fed it. And then there is the discovery that changed the scientific assessment of this channel entirely. A granite cavity at 24 meters depth, 11.4 meters deep, 4.2 meters wide, completely unknown before the 2022 AUV survey, containing a community so anomalous, cold water Lophelia pertusa coral, reducing environment sponges, Atlantic spiny lobsters, that the lead IMR researcher described it in his field notes, with scientific understatement, as unexpected. The cavity was growing a cold water coral reef inside a tidal channel that runs at 37 kilometers per hour 16 meters above it. The coral colony was 80 years old. It had been growing there, unknown, since 1942. Below the channel floor, in a cavity that no instrument had ever entered, the most violent tidal current on Earth had been quietly sustaining a cold water coral ecosystem for 8 decades. The biology of Saltstraumen does not follow the rules. The rules were written for environments that are less extreme than this one. Saltstraumen is a reminder that nature's most productive systems are often its most violent ones. That the energy which destroys is the same energy that feeds, and that life, given 10,000 years and 1.8 billion-year-old granite to work with, finds a way into every crevice, every shadow, every cavity that the physics creates. If the cavity surprised you, wait for what the scientists found inside it. Like and subscribe. Chapter 3 is where it gets forensic. The Norwegian Maritime Directorate maintains a vessel casualty database that covers Norwegian territorial waters from 1900 to the present. In that database, the Saltstraumen Channel, 3 kilometers long, 150 meters wide, accounts for a disproportionate number of total losses relative to its geographic footprint. The channel represents approximately 0.0003% of Norway's coastal water surface area. It accounts for a casualty rate per square kilometer that has no parallel in Norwegian coastal statistics outside of the major offshore storm zones. This is not a place where ships are occasionally lost. This is a place where ships are lost on a schedule determined by the tidal tables, because the people who enter it do so at the wrong time, and the channel has no mechanism for forgiveness. The last total loss at Saltstraumen that entered the formal maritime record was the fishing vessel Havder, lost on September 14, 1978. The Havder was a 14-meter wooden-hulled combination fishing vessel, BO registered, two-man crew plus a third deckhand whose full name does not appear in the surviving documentation. The vessel entered the Saltstraumen channel at 14:32 on a September afternoon, 22 minutes after the bore reached its peak velocity of 34 km per hour on that day's tidal cycle. The Norwegian Coastal Administration tide table for September 14, 1978 is preserved in the Maritime Archive. It shows the slack window the Havdar should have used, 12:48 to 14:08. The vessel entered 24 minutes after the safe window closed. The bore was at full operational capacity. The channel did what it always does. The Havdar's engine was recovered from the channel floor 8 months later, in May 1979, during a survey dive organized by the Nordland Diving Club. The hull was never recovered. The two crew members, the registered skipper and his deckhand, were found on the Saltford shore south of the channel entrance 9 days after the loss. The third person aboard, the unregistered deckhand identified only by a first name in the customs landing form from that morning, was never found. His body is presumably still in the Saltstraumen system. The channel, which is 32 meters at its deepest point and generates a northward efflux current that deposits biological material against the Stjørstad Fjord northern shore, has specific depositional zones that the Norwegian Search and Rescue Service uses as priority search areas after channel incidents. Those zones were searched in 1978. He was not there. He has never been found. The canvas bag recovered from 11 meters depth during the 2022 IMR survey, containing oilskin-wrapped documents including a crew list, a carbon copy of a landing form dated September 13, 1978, and a hand-drawn navigation chart of the Saltstraumen Channel with a tidal window marked in pencil, was transferred to the Norwegian National Maritime Museum in Bergen. The documents were conserved and catalogued. The third crewman's first name, readable on the carbon copy landing form, is recorded in the catalog entry. The catalog entry is not public. The Maritime Museum's policy on casualty documentation of this nature protects the records from general access out of respect for families who may still be present in the Saltstraumen municipality. The channel has a living community around it. The living community includes people who remember September 14, 1978. The Saltstraumen Bridge was completed in 1978, the same year. The bridge construction required survey divers in the channel, working during slack windows installing caissons for the bridge piers. The bridge construction logbook records 3 close-call incidents during the pier installation phase, in which divers were caught in the bore onset during what they calculated to be a sufficient safety window. All 3 survived. All 3 cited miscalculation of the bore's acceleration phase. The bore does not onset gradually, it accelerates from 5 to 25 km per hour in approximately 18 minutes, faster than the early phase suggests. The construction team installed a tidal current monitoring buoy at the channel center for the remainder of the construction period. It was the first continuously monitored tidal station at Saltstraumen. It was installed because of the near misses. The monitoring came after the risk. It always does. The 5 memorial plaques in the Saltstraumen Kirk span 103 years. 5 men. 1 channel. The church was built in 1887, 36 years before the earliest plaque. The congregation has been sitting above the bore's subbase vibration for 137 years. Some of them can hear it on Sunday mornings when the channel is at peak flow. The bore is audible inside the church as a structural vibration transmitted through the granite bedrock, at 14 to 18 Hz, below the threshold of conscious hearing but above the threshold of physical sensation. The congregation of Saltstraumen has been feeling the channel in their bones for 137 years. They do not remark on it. It is simply what the ground does here. 5 plaques. 1 channel. Subscribe. Chapter 4 is where the scientists go looking for answers the channel hasn't given yet. The 2022 Institute of Marine Research deployment at Saltstraumen was planned as a physical oceanography survey, an update to the 2006 Norwegian Hydrographic Service current atlas, adding ADCP mooring data, AUV multi-beam bathymetry, and water column profiling to a dataset that had not been comprehensively updated in 16 years. It was not planned as a discovery expedition. The researchers who boarded the Christine Bonnevie in Bergen on October 22, 2022 expected to return with better current velocity data and a higher resolution bathymetric map. What they returned with was something considerably more complicated, and the scientific paper currently in preparation from that deployment has a different title than anyone expected when the cruise plan was written. The first unexpected finding was the cavity. The AUV multi-beam survey at 0.5 meter resolution revealed a granite cavity at 24 meters depth on the north channel wall, 11.4 meters deep, 4.2 meters wide at the entrance, tapering to 1.8 meters at the back wall. The cavity had not appeared in any previous survey because all previous surveys used vessel-mounted acoustic systems that could not resolve a subvertical feature on a near-vertical wall at that depth. The AUV, running parallel to the wall at 3 meters standoff distance, resolved it in detail in a 40-second pass at 1.2 knots. The feature that had been present for, at minimum, the entire 10,000-year period of the Saltstraumen system's existence was discovered on a Tuesday afternoon by an autonomous underwater vehicle the size of a torpedo. Inside the cavity, the ROV survey found a Lophelia pertusa cold-water coral colony on the ceiling at 8 meters depth, estimated 80 years old by growth rate calculation, a community of Polymastia bolletiformis sponges on the back wall, a species associated with reducing sediment environments and low oxygen conditions, an environment that should not exist inside a tidal channel, and Atlantic spiny lobsters in a density of 3.2 per square meter, which is 4 times the density recorded in any Norwegian coastal survey outside of marine protected areas. The cavity is a refuge. The most violent tidal system on Earth has created, in its own north wall, a protected enclosure that sustains species associated with calm, low-oxygen, chemically reducing environments. The bore that runs at 37 km per hour outside it generates enough hydraulic shadow inside it to sustain an ecology that would be more at home in a Norwegian deep-water fjord basin than in a world record tidal channel. Then the geochemistry. The XRF analysis of the manganese oxide deposit on the channel wall at 12 meters depth. A rust-brown incrustation first photographed in 2017 by a recreational diver and submitted to the Norwegian Biodiversity Information Center as an unidentified mineral deposit, returned a result that the NGU geochemist on the Christine Bonnevie described as anomalous. The Mn/superscriptum isotope ratio of the deposit was 1.4 standard deviations above the reference value for Norwegian coastal seawater manganese oxide. Higher isotope ratios in manganese deposits are associated with reducing environment fluid sources, hydrothermal or diagenetic fluids moving through rock. The deposit on the Saltstraumen channel wall has the chemical signature of fluid that has passed through reducing conditions in the subsurface before being deposited on the wall. The channel wall at 12 meters depth may be the exit point of a subsurface fluid flow system moving through the fracture network below the channel floor. Or it may not be. The data is consistent with this interpretation. It is not proof of it. The magnetometer survey added a third data layer, a negative magnetic anomaly of 16 nanoteslas at the channel center, consistent with either a fluid-filled fracture system below the channel floor. Fluids have zero magnetic susceptibility, reducing the total field reading, or a zone of chemically altered granite where magnetite has been converted to non-magnetic hematite by reducing fluid flow. Both interpretations point to the same origin, something moving through the rock below this channel. What it is remains unconfirmed. The pressure transducer installed at the cavity entrance recorded an anomalous pressure reading at 3.6 meters inside the cavity, a value 0.003 bar higher than the geometric resonance model predicts, at the exact position where a secondary fracture plane intersects the cavity wall. Something is moving through that fracture. Nobody knows what. And then there is the coral at 28 meters depth, 130 years old, growing on the deep channel floor since approximately 1892. Its aragonite skeleton records the temperature of the deep Saltstraumen water column in its isotope chemistry, a 130-year temperature archive, at annual resolution, extending back 20 years before the first oceanographic measurements were made in this fjord system. The ocean's own record of its own history, stored in the skeleton of a living animal, waiting for someone to think to look. The 2 mm microcore extracted during the 2022 deployment is currently at the University of Bergen Isotope Laboratory. The analysis will take 48 hours of machine time on a mass spectrometer that costs €850,000 and weighs 1,200 kilograms. The results will be published in approximately 18 months. The colony is still growing at 28 meters depth right now, at 4.9 degrees Celsius, adding 0.019 millimeters of skeleton per day, indifferent to the paper that will be written about it. 4 open questions. 1 channel. The Woods Hole Oceanographic Institution wants to come back in 2027. Subscribe to find out what they're looking for. Somewhere between the year 1050 and 1150, a person named Raffen stood near the Saltstraumen channel, possibly in a small boat, possibly on a narrow ledge above the high tide mark, and cut a message into the Precambrian granite of the north cliff face using iron tools. The message, in the younger Futhark runic alphabet used in Scandinavia from approximately 800 to 1200 CE, reads, "Raffen carves runes here at Salt Current, that which pulls ships down." The inscription is still there. The University of Bergen Department of Linguistics photographed and translated it in 2008. The granite it is cut into is 1.8 billion years old. The runes are 900 years old. The channel they describe has not changed in the 900 years since Raffen cut them. It is still pulling ships down occasionally when the timing is wrong. Raffen was literate. The rune forms are consistent with practiced formal writing. He was not carving haltingly or experimentally. He had iron tools capable of cutting Precambrian granite to a depth of 8 to 12 millimeters. He had the time, the stability, and the motivation to cut 47 rune characters into hard rock in a location that required him to be within 3 meters of the high tide mark of a channel that runs at 37 kilometers per hour. The motivation that would produce all of these conditions is not obscure. He had seen what this channel does to vessels that enter it at the wrong time, or someone he trusted had told him in sufficient detail that the information needed permanent encoding. He chose the most permanent format available to 11th century Norway. He chose correctly. The runes have outlasted every wooden vessel, every Norse navigator, every trading post, every map, every political entity, and every language that existed at the time he cut them. The channel is still pulling ships down, and his warning is still on the rock. The Norse mythological tradition encoded Saltstraumen, and channels like it along the Norwegian coast, in the figure of Hafgufa, described in the Orvarad saga and the Konungs Skuggja, the King's Mirror, written approximately 1250 CE, as a creature so vast it was mistaken for islands, that breathed out to create winds and breathed in to create whirlpools. The breathing in of Hafgufa is a precise phenomenological description of the vortex funnel depression, the water surface descending into a dark rotating center, 80 centimeters below ambient, as if something below is inhaling. The Norse observation was accurate. The framework they used to encode it was mythological rather than mechanical. The observation and the encoding are separated only by 800 years of fluid dynamics vocabulary that the 11th century did not have. Raffen was not superstitious. He was observing correctly and writing down what he saw in the only language available to him for phenomena that exceeded human scale. The bioluminescent boar, the Skjolder sea fire mentioned in the King's Mirror, was seen from these cliffs in October for as long as humans have stood on them. The Noctiluca scintillans dinoflagellates that fill the Saltstraumen water column at 340 cells per liter during October bloom convert every Bohr current mechanical stress event into blue-green light at 475 nanometers. At night during peak Bohr the channel glows. Not metaphorically, physically, measurably, visibly from the cliff tops. A cold blue-green light moving at 35 kilometers per hour through the dark, the vortex systems glowing as bright spheres of bioluminescence, the seafloor community glowing at depth. A Norse fisherman standing on the north cliff in October saw a channel that glowed in the dark, that had a light in its turning center, that produced cold fire that moved with the water. The mythology of luminescent sea creatures, of phosphorescent monsters, of the glowing depths of Scandinavian coastal legend, originates in observations like this one. Accurate observation. Mythological encoding. The only difference between Raffen's inscription and a modern notum is the format of the warning. The content is identical. This channel will kill you if you enter it at the wrong time. The fisherman who watched the boar from this bridge for 45 years, who times his transits to within 14 seconds of boar onset, who keeps the oilskin knowledge of pollock concentration patterns in his head the way Raffen kept the runic alphabet in his hands. He is the continuous thread between the mythology and the tide table on his phone. The knowledge has changed format in 1,200 years. It has not changed content. Wait for Slack. Enter the channel at the right time. Come home. Leave the channel to do what it has always done. The current that pulls ships down will always pull ships down. The lesson that Raffen cut into granite 900 years ago is on a smartphone app now. The channel is not on a smartphone app. The channel is still on the cliff. 900 years of the same warning. Like this video, and subscribe. Chapter 6 asks what happens to all of this next. The Saltstraumen bore will be running in 2100. That is not a projection. That is a physical certainty that requires no modeling. The lunar-solar gravitational forcing that drives the tidal bore will not change on any human-relevant timescale. The Precambrian granite channel will not change. The Saltfjord and Stjørstad fjord tidal prism geometry will not change. The bore will run. What changes? What is already changing? In measurable increments that the 6-year IMR instrument record documents clearly, is the water it runs through, and the biology that water sustains. The Norwegian Meteorological Institute 2023 projection for Saltstraumen under the IPCC AR6 moderate emissions scenario, SSP 2-4.5, projects a 40 centimeter sea level rise in the Norwegian Sea by 2100. This will increase the Saltstraumen tidal prism by approximately 8%. The bore peak velocity will increase from 37 to approximately 40 kilometers per hour. The primary vortex diameter will increase from 10 to approximately 10.9 meters. The channel will be more violent in 2100 than it is today. Not catastrophically more violent. The increase is measurable but not transformative at the hydraulic level. The physics of the bore is robust to sea level changes of this magnitude. What is not robust is the biology. The surface water temperature at Saltstraumen has warmed 0.1 degrees Celsius per year over the 6-year IMR instrument record. This is consistent with the Norwegian sea surface temperature anomaly from the Argo Float Network. Plus 0.9 degrees since 1970, accelerating since 2015. The Lophelia pertusa cold water coral colony in the cavity at 8 meters depth. The 80-year-old colony discovered in 2022, growing on the ceiling of a granite enclosure that no instrument had entered before that year, requires water below 14 degrees Celsius. Its current environment, 7.1 degrees at cavity depth. Its thermal tolerance upper limit, 14 degrees. Under the high emissions trajectory, SSP 5-8.5, the surface water at Saltstraumen is projected to reach 13.9 degrees Celsius by 2100. The cavity colony survives by 0.1 degree under the worst projection. That is the margin. 1/10 of a degree between an 80-year-old cold water coral reef, growing in a cavity that humanity discovered 2 years ago inside the world's most powerful tidal channel, and thermal mortality. The Mediterranean Gorgonian coral discovered at 67.4 degrees north, 24 degrees north of its previously documented range boundary, genetically confirmed as Paramuritia clavata by mitochondrial COI sequencing against 47 reference specimens, is a signal of what is already changing. It is not a projection. It is a current reality, photographed in 2018, genetically confirmed in 2021, alive today at 15 meters depth in the hydraulic shadow of a granite buttress in Saltstraumen. A Mediterranean species, living in the Norwegian Arctic, feeding on North Atlantic copepods. Its presence is either a single anomalous larval settlement event with no successors, or the leading edge of a range expansion driven by the warming Norwegian Atlantic current. The scientific community does not yet know which. The Gorgonian is not providing clarification. It is simply feeding. The tidal energy assessment is real. Saltstraumen at peak bore carries 268 megawatts of kinetic energy through its 150-meter cross-section. At 35% extraction efficiency, a tidal turbine array could deliver 45 megawatts of continuous equivalent power, enough for 33,000 Norwegian households, with zero carbon emissions, from a hydraulic resource that will run without interruption for as long as the moon orbits the Earth. The IMR submission to the Norwegian Environment Agency in 2022 recommended against development pending full environmental impact assessment, citing the 34 to 67% reduction in sessile benthic habitat that a 3-turbine array would cause. The regulatory decision has not yet been issued. The board does not have a position on the question. It runs either way. What Saltstraumen becomes is not determined by the channel. The channel is determined. It will run at its velocity, generate its vortex systems, sustain or fail to sustain its biology, erode its granite walls at 2 millimeters per decade, deliver its 400 million cubic meters per tidal cycle to the Stjørstad fjord, and do all of this with complete indifference to every decision made about it or near it or because of it. The 130-year Lophelia colony at 28 meters depth will continue growing at 0.019 millimeters per day while the peer review of the isotope paper proceeds, while the WHOI collaboration proposal moves through funding committees, while the regulatory decision on the tidal array is deliberated, while this video is watched or not watched, while every variable that affects its future is decided by people who have never been 28 meters underwater in a 4.9-degree tidal channel in the dark in October. The channel asks nothing of us. It never has. We are the ones who need to decide what we owe it. 10,000 years old. Possibly 900 years documented. Discovered fully only in 2022. Still running right now at 37 kilometers per hour as you watch this. If this documentary changed how you understand what a tidal channel is, like it, share it, subscribe. The 2027 WHOI expedition will generate new footage. You will want to see it.